Hello, and welcome to this tutorial for BioXTAS RAW. In this tutorial, you'll learn how to set absolute scale in a calibration file for reducing two-dimensional images to one-dimensional scattering profiles in RAW. This approach uses the glassy carbon NIST SRM 3600 as the absolute scale reference. This approach requires the RAW tutorial data available on the RAW website. Before we begin, I want to note two things. First, you can either use water or the NIST glassy carbon standard for absolute scaling. The NIST glassy carbon standard should be more accurate. Second, if you use the glassy carbon, there are two ways to do this in RAW. One follows the full NIST protocol, which we will describe later on in this tutorial, which nominally should be more accurate but requires having other available measurements. One uses what I call a simple approach, which seems to be fairly accurate and relies on fewer moving parts. So with that, I'm first going to go through the simple normalization to absolute scale with glassy carbon, and then we'll do the full NIST approach. If you've already done the previous tutorials on creating a configuration file, you should load in that configuration file now. If you haven't, in the calibration data folder of the tutorial data, you should load in the settings file, which I will do now just by double-clicking on it. So now what we're going to do is plot both of the glassy carbon standards by clicking plot. Then I'm going to average them and save them, or save the average. Now we're going to open the advanced options window and go to the absolute scale. So here what we want to do is we want to set the glassy carbon to the glassy-carbon.dat file that we just saved. We're not going to add in an optional calibration file. You should set the thickness according to the SRM 3600 calibration document that came with your standard. 1.055 is the standard thickness. Set the sample thickness to 1.0, which is the path length of the sample capillary that's used at this beamline. And then click Calculate to calculate the absolute scaling constant. It should be about 324, as you can see here. We're then going to check the normalized process data to an absolute scale using glassy carbon, and click OK. Now we can save the settings for future use if we want. With that, you should now know how to do the simple approach for calibrating with glassy carbon. So now we're going to go through the full approach. Note that I don't have the data available in this calibration folder to do the full approach, so we're going to go into the extra folder and use the data in here. So to start with, we're going to load up the SAXS calibration file here, which I've just done. Now we need to remove the normalization, because normalization happens as part of the absolute scaling in this approach. So I open the options, go to normalization, I select that in the menu, and I click delete. Now I'm going to go to the absolute scale, and I'm going to make sure that the absolute scaling is turned off before I load anything in. Next, I'm going to plot the glassy carbon files. Actually, I'm going to plot just the first glassy carbon file, which I'm going to remove the previous one we had here. And I'm going to save this, reduced.dat file. I'm going to do the same thing for the vacuum here. Note just one of the files, and for the MT2, which is the empty cell. And I'm going to save both of those. Now we're going to go back to the advanced options and go to the absolute scale. Here I'm going to uncheck ignore background. So now I'm going to set the glassy carbon to this glassy-carbon.dat that I just saved. I'm going to set the glassy carbon background to the vacuum. This is a measurement of the background in the system when we made the glassy carbon measurements, which is this vacuum scattering. And then I'm going to set the sample background of the empty cell. This is the empty capillary, so this is the intensity that the background intensity that gets measured whenever a sample is measured. In this case, the sample thickness is 1.5, so I'm going to set that. We also now have to set the calibration, so we need to know what there has to be a counter measuring the upstream intensity. In this case, that is the I1 counter, and a counter measuring the downstream intensity, the intensity downstream of the sample, usually a beam stop counter. In this case, that's I3. We now click the Calculate button, and we should get about 198, as we do here. So you can see that this has a lot of moving parts, right? It depends on knowing the glassy carbon instrument background, the background for the sample cell, having this upstream counter, this downstream counter. When we set this is going to carry out all of the normalization as well as doing the absolute scaling all in one step. The downside is it really depends on having stable backgrounds, having good measurements here, and it could introduce a lot of uncertainty if those aren't solid. This is why I prefer the simple approach that we did first. So now we can go ahead and we can check this normalized process data at absolute scale using glassy carbon, and then click OK. At this point, we would be clear to save the settings for future use. As a final note, in my experience, the difference between these two methods for calibration usually agrees to within 1.5%. The best approach is going to depend on how strong your background scattering is relative to the rest of the scattering of the system and how stable it is, along with whether or not you have a measurement of both the incident and transmitted intensity. With that, that's the end of the tutorial. You should now know how to calibrate scattering intensity to an absolute scale using glassy carbon in RAW.